Robot Metabolism, the future of self-healing modular robots explained. Revolutionary self-evolving robots mark dawn of mechanical metabolism, and we're not ready. Tetrahedron-shaped machines that consume each other to become stronger. Sounds like science fiction, right? But this breakthrough is happening right now at Columbia University, and the implications could transform everything from disaster response to space exploration. Here's where things get truly mind-bending. A Fort Worth-based engineer and futurist, Charles Wilson, recently spotlighted what he calls an absolutely mind-blowing robotics trend, after discovering groundbreaking research from Columbia University's Creative Machines Lab. The innovation? Modular robots with the unprecedented ability to reconfigure themselves, and even cannibalize their mechanical brethren to heal damage and enhance their capabilities on the fly. The technology centers around what researchers have dubbed Truss Link robots, distinctive tetrahedron-shaped units equipped with magnetic joints allowing for rapid reconfiguration without human intervention. In one particularly striking demonstration that Wilson highlighted, a robot boosted its walking velocity by an impressive 67% after incorporating a new limb harvested from a nearby unit. This scientific leap, detailed in a paper published in Science Advances, introduces the revolutionary concept of robot metabolism, an autonomous, self-sustaining process enabling machines to absorb and repurpose components from their environment or from other robots. Think of it as mechanical digestion and growth, but for machines. The pioneering work received support from both the NSF AI Institute in Dynamic Systems and DARPA's TRADES program, signaling its significance to multiple sectors including defense. For robots to achieve true autonomy, they must not only possess the capacity to think independently but also physically maintain themselves, explained Philippe Martin Wider, the study's lead author, underscoring the fundamental shift this represents in robotics design philosophy. Hod Lipson, director of the lab and co-author of the study, offered context for why this matters. While robot intelligence has advanced tremendously through machine learning breakthroughs, their physical embodiments have lagged significantly behind. Most robot bodies remain monolithic, unadaptive, and fundamentally unrecyclable. Lipson acknowledges that the concept of self-reproducing robots inevitably conjures some potentially concerning sci-fi scenarios in the public imagination. However, he counters with a pragmatic observation. As we increasingly delegate critical aspects of our lives to robots, from autonomous vehicles to automated manufacturing facilities, and increasingly defense systems and space exploration, we simply cannot continue relying solely on human intervention for their maintenance. Eventually, robots must develop the capability to care for themselves. The transformative potential of this technology isn't lost on Wilson, who holds an MBA from TCU's prestigious M.J. Neely School of Business. He envisions expansive real-world applications that could reshape numerous industries. Imagine the possibilities in disaster zones or remote space missions, where these machines could adapt without human assistance. Wilson wrote in his analysis. This fundamentally transforms our workforce landscape from rigid, single-purpose tools to resilient, adaptive machines and collaborative robotic teams. Wilson concluded his thought-provoking post with challenges directed at the innovation community. Engineers and innovators, in what ways might this technological leap revolutionize disaster response protocols? Startups, are you prepared to build upon the foundation of robot metabolism for commercial applications? But here's the question that keeps roboticists up at night. At what point does mechanical self-maintenance cross the threshold into true self-replication? And are we prepared for the ethical dilemmas that such technology inevitably raises? The line between helpful autonomous systems and the stuff of dystopian warnings seems increasingly blurry. Do you believe the benefits of self-maintaining robots outweigh the potential risks? Or should we proceed with greater caution before developing machines that can essentially reproduce? Share your thoughts in the comments below. For an eye-opening demonstration of these Truss Link robots in action, view Columbia University's video demonstration. Stay current on all the latest North Texas innovation stories by checking out Every Last Word. Don't miss what's coming next in the rapidly evolving tech landscape. Subscribe to Dallas Innovates. Keep your finger on the pulse of Dallas-Fort Worth's business and innovation ecosystem with our carefully curated news delivered directly to your inbox Tuesday through Thursday. Revolutionary robots, the future of self-sustaining machines. Imagine a world where robots not only think independently but also sustain themselves physically. This isn't a scene from a sci-fi movie, it's a groundbreaking reality brought to life by researchers at Columbia University in New York. They've introduced a revolutionary concept where robots can grow, heal, and even eat other robots to maintain themselves. This development opens up an entirely new dimension of autonomy and artificial intelligence, marking a significant leap towards truly self-sustaining machines. Philippe Martin-Weider, the lead researcher from Columbia Engineering and the University of Washington, explains that true autonomy encompasses more than just intellectual independence. Just as living organisms absorb nutrients to grow and repair, these innovative robots can now self-repair and evolve by utilizing materials from their surroundings or, more intriguingly, from other robots, he states. This process, known as robot metabolism, enables these machines to integrate and repurpose parts of other robots. The researchers demonstrated this concept with a device called the Truss Link, a robotic component that can expand, contract, and magnetically connect with other parts. This capability allows the robot to self-assemble, enhancing its functionality by adding new components or discarding obsolete ones. For instance, a tetrahedron-shaped robot was shown to attach a new truss link and use it as a walking stick, boosting its speed by over 50%. But here's where it gets controversial. The notion of robots consuming each other raises ethical and practical questions. What are the implications of self-sustaining robots in our society? The team envisions these robots playing pivotal roles in scenarios like ocean exploration, disaster response, space colonization, and everyday assistance. Robot metabolism not only bridges the digital and physical realms but also enhances the physical capabilities of AI, creating a new layer of autonomy, Dr. Weider elaborates. Initially, this technology might be applied in specialized fields such as disaster recovery or space exploration, but the potential extends to AI constructing physical structures autonomously. And this is the part most people miss. The broader implications of such technology could redefine our interaction with machines. As these autonomous robots evolve, they could become integral to our daily lives, much like smartphones today. What do you think about the future of robots with such autonomy? Could this lead to a new era of innovation, or might it pose unforeseen challenges? Feel free to share your thoughts and join the discussion.